So number 10, I want to use log properties first. So before I take the derivative, so this is still f of x, I'm going to rewrite this as ln of secant squared of x minus ln of x cubed. Then I want to bring those exponents down, right? Because you know this is, I'm just going to emphasize this is to the squared power. And since that's to the squared power, even before taking the derivative, I can bring the 2 down in front. And then minus, and I can bring the 3 down in front. Okay, let's take the derivative. So if I carry the 2 along, derivative of ln of secant would be 1 over secant times the derivative of secant, which is secant tangent, and then subtract 3 times the derivative of ln of x, which is 1 over x. So these two secants cancel, so I get 2 tangent x minus 3 over x. So that is so much easier than if you had done quotient rule. Oh my goodness, so much easier. So make sure you're thinking about the ln properties and how they can help you. Okay, so let's look at this one. So let's think about this is ln, and this is x squared plus 16 to the power of 1/2. So let's just make sure you would never say the square root of x squared plus 16 is x plus 4. That would be such bad math, right? Bad math. Okay, but what you can do, since it's ln, I can bring that power down in the front, and I get that. So now I'm ready to take the derivative. So the derivative is the number 1/2, 1 over x squared plus 16, 1 over stuff, times the derivative of stuff. So those 2's I can see cancel, so I just get that. That's it. Okay, so let's look at this one. Ooh, this is a little uglier. So I'm just going to rewrite it. So this is like saying ln of inverse tangent of e to the negative x. This negative 1 is not an exponent. It means arctangent, right? So this negative 1 cannot come down in the front. So we just have to do it as it is. So first off, we take the derivative of the ln. So that's 1 over arctangent of e to the negative x. Next, we multiply by the derivative of the arctangent. So that's 1 over 1 plus stuff squared, and the stuff is e to the negative x. Now we take the derivative of the stuff. So the derivative of e to the negative x is e to the negative x times negative 1, and that's a fine answer. Oh my goodness, the implicit comes up with the ln's also, and the logs. It sure does. Okay, so let's try it. So if I'm going to take the derivative, so again, I'm taking the derivative with respect to x on both sides, and always be thinking, are there log properties I could use? This x squared is inside the secant, so nothing happens over here. That's fine. But what do you notice here? That is multiplied. If I have multiplication inside an ln of AB is equal to ln of A plus ln of B. It would be so helpful to do that first. So I still haven't taken the derivative. Ln of x plus ln of y. Still going to take the derivative equals derivative log base 3 secant of x squared. Okay, so let's go do it. So derivative of 1 over x, or I'm sorry, the derivative of ln of x is 1 over x. Derivative of ln of y is 1 over y prime. All right, let's tackle this guy now. So derivative of log base 3 is 1 over ln of 3 and then stuff. So carry the stuff along. Now I'm going to take the derivative of the stuff, right? So take the derivative of the secant. So that's secant tangent. And remember, it's useful to leave a space for the angle that I'm carrying along. And since I carried along the angle, I multiply by the derivative, which is 2x. Okay, so where is the y prime? Oh, look at that. There's only one y prime guy. So if I subtract that over. So I'd have 1 over y prime equals, let's just carry, whoa, look at that. I think I see a secant of x squared canceling, right? Okay, so carrying this along, I'd get a tangent of x squared times a 2x all over ln of 3, subtract a 1 over x, and then to finish it off, I would say y prime, right? I'd have to multiply by y. Y times tangent of x squared times 2x over ln of 3 minus 1 over x. You're noticing you need a lot of paper, right? Yes.